You guys just
You have two right over there.
about it.
I know, but we're creating Hawaii.
No.
What? I'm gonna throw out Hawaiian.
Matilda's
I'm gonna
nose
veto
is
this.
Veto.
not right. Just no.
This is a
Okay, so yes, we'll talk about that. So, student will be able to use perpendicular bisectors to find measures and circumcenters of triangles. Section 5.1. Chapter 5 still talks about triangles. We're still talking about triangles in Chapter 5. Awesome. So, in Chapter 5, talking about properties of triangles. The first property we're going to talk about is perpendicular bisectors, okay? Perpendicular, what's perpendicular mean? 90-degree angles, very good. Bisect, what's bisect mean? They connect, they split, they intersect. They bisect, they split right in the middle. So it's supposed to do it in two halves, right? Okay, so perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. Midpoint is the middle point of a segment, right? So it cuts the segment into two congruent parts. It cuts the segment into two congruent parts, two halves, right? Two halves make a whole. Now here, what is the perpendicular bisector of segment AB? Okay, so it could be, because it could just be a point, but we're talking about the line, so PC or CP. Someone said, Faith said CP, so we'll call it CP. Okay, so line CP is the perpendicular bisector of segment AB. It cuts it in half, bisects, and is perpendicular. So line CP is a perpendicular bisector of segment AB. Hey, basically everything we do has a theorem attached to it, right? Why not? So perpendicular bisector theorem, if a point is on the perpendicular bisector of a segment, then it is equidistant.
Why can't we just say equal distance?
It is equidistant from the two endpoints of the segment. Equidistant. What's equidistant going to mean?
Equal
Distance, right? Okay. Same distance from, so it's equidistant from the two endpoints of the segment.
That's
Okay.
the most ridiculous word I've ever heard. Like, cheese is on fire. Like, wait.
Okay.
Literally, you took out the F.
And an A. And change it to an I.
Better side things too, you know.
Okay, so
Change
you took
distance
out
to distance.
And
took out
even
a
lowercase.
letter.
And a space.
You took a letter. You changed the letter and took one out,
Okay.
and then changed the second word slightly, and decided to combine it. That's the dumbest thing I've ever heard in my entire life.
I didn't make it up.
You could just say equal distance. Two lines.
You didn't have like
Yeah,
equal
like,
distance, so you shouldn't have it.
Okay.
What? You go, bro.
Where's you
What's up
going?
with that triangle?
Okay. Let's focus on this far right image. Actually, let's focus on this far left image. So here, we're going to ignore this part. So here, this is like the same thing we had up here, except we added in an X, right? We're saying X is on this perpendicular bisector CP, correct? It's on the perpendicular bisector. We said CP, line CP was our perpendicular bisector. It's on that. So according to this, since it's on the perpendicular bisector, what must be true? It's equidistant from the endpoints of the segment. It's the same distance from both point A and point B. That distance is going to be the same.
Oh my gosh.
So point C is also going to be the same distance away from points A and point B.
Oh my goodness. Whoa.
Okay? What this also says is we could create infinitely many points continuing down on this perpendicular bisector. We could have point W down here, and this would also be equidistant from points A and points B, the endpoints of the segment which is perpendicularly bisected.
I'm not drawing that. That is so cool.
Take a exit, come back down to sit down and
It's pretty neat. I think
It
it's a pretty
is.
neat one. So
It's definitely the most interesting thing we've learned.
Yeah.
no.
It's the fact that you're find the word.
Menards?
Mind
Isn't that
boggling.
where he works?
Yeah.
Mind boggling.
Bazonga.
It's very butt hurts.
Oh yeah.
What a guy.
Yeah. He's a good guy. I like him. So anyway, hey, does this kind of make sense? How it's gonna be equidistant everywhere it goes? Pretty cool, okay? Pretty neat. Okay? So we're actually gonna get rid of that too. Hey, so this is an if-then form, right? What have we had with other if-then things?
Those
Then it-
statements.
The
Converse.
converse.
Oh,
We
no.
reverse the order. We keep the if first and then second, but we change out causes and conclusion. Guess what we're gonna do with this one?
Converse.
Converse. Woo! So instead of saying if the point is on the perpendicular bisector of the segment, then it's equidistant from the endpoints. We're gonna reverse it, saying if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment.
Why are there so many laws? This is math.
Upside down T.
This is math.
Of the.
So, if XA, the distance from the endpoint to a point on, right here, if XA is the same distance as XB, if a point is equidistant from the endpoints of the segment, this point is equidistant from the endpoints of AB, then it must lie on the perpendicular bisector of segment AB. So it's just saying it in reverse. Does this make sense?
What's that,
Perpendicular bisector of the segment.
I actually fit all the words on the
Dang.
line.
Yeah.
I didn't, I ran out of words. I also
Okay.
ran
Upside down T.
Questions on this?
I just did the little thing that I put bisector.
All right, let's use it. Woo! Okay, let's use it. Yeah, woo, math. Yeah, math. Woo, math. Okay. Extra example one. It's not extra for us. It's not extra. It's just a normal example one for us. But anyway, in the diagram, we have this line RS, and it's the perpendicular bisector of segment PQ. Okay, perpendicular means PS is congruent to segment SQ, correct? Perpendicular bisector. Perpendicular to that, I drew the box. Bisector, I drew that in. Okay? So we're supposed to find PR. Wait a second. How do we find PR if we only know that PS, segment PS, and segment SQ are congruent? How can we find segment PR? So we're supposed to find, how can we find it?
Wait.
What about this perpendicular bisector theorem we just learned? What's that say?
Wow.
If a point is on the perpendicular bisector of a segment,
Oh,
is
the
R,
Those lines.
then it's equidistant from the endpoints. Is R equidistant? So is R on the perpendicular bisector of segment PQ?
Yeah.
So
Yes.
8x minus 9.
Yeah, so 6x is equal to 8x minus 9.
Our whole class.
Because this point R is on the perpendicular bisector of the segment.
Wow.
That's
So can we solve this equation?
Yeah.
Okay, negative 2x is equal to negative 9. You guys track where I went with that one?
No.
Subtract 8x, subtract 8x.
Oh.
Can we get the x's by themselves away from the constant?
Yeah.
Okay, divide by negative 2. What's x? Okay, but are we supposed to find x?
No.
Ooh, our final answer is PR, almost tricky, okay? So what do we do to find PR? Put it in the expression 8x minus 9. So 8 times 4.5 minus 9. What is 4.5?
A number.
What is 4.5 times 8? Nice.
Be on your way.
36.
True. 20,
36.
36, that sounds better. 36 minus 9, which is 27. So the measure of segment PR is 27.
Don't you just done 6 times 4.5?
Yep.
Would've been a lot easier.
Jacob said, hey, could we do 6 times 4.5? How could we do that the same thing as we did this? Because they're congruent.
Because we want it to be extra.
Yeah, literally
Just like
extra
creating
equals
words.
1, so.
So,
It's like on those
I digest.
YouTube videos.
So,
Like, I'm just a little
Like just a little extra.
Yeah.
okay, let's go to example 2.
Why do I have zero room to do anything?
Because
Okay.
paper.
Oh, yeah.
We're saving trees, boys.
Whoops. I fit it on there.
Oh, wow. I wonder how. Because you're extra.
See, I fit it on there. did all the work. Bet.
This morning in Spanish, I had like a pile of change on my table because I was planning on going and buying coffee after, and I was working on something, and Miss Olson just comes up to my desk and slides the money off and sticks it in her pocket, and I'm like, excuse me, hello, that is my coffee money. And she's like, you don't eat coffee, I need a pop. And I was like, what? And so then she goes, okay, if you get all of these right, then you can have your money back. And I got them right.
Ooh, blackmail.
That'd be scary.
Maybe that's called theft.
No, and it was really sad.
Riley, if you get all these right, you can have your phone back.
Like it was
Give me
really,
your Switch.
it was.
Okay.
You imagine right now, like, all right, get this right.
Cop a switch. Okay. Hey, so in the diagram, segment JK or line JK is the perpendicular bisector of segment GH. Okay, so line JK, just kidding, Josie Knust, is the perpendicular bisector of segment GH. So we can mark that as already perpendicular. And we can mark that. Okay.
Oh, yeah, she knows by now.
So
It's not as bad as when people say.
I used to it.
It's not as bad as when people say like I'm gonna kill myself and then he walks up.
I'm not gonna kill myself. I'm Mr. Carlson. Okay. So what segment lengths are equal if we know that line JK is a perpendicular bisector of segment GH? Faith. Okay, we know that segment GK is going to be congruent to segment KH. Do we know anything else?
What do you mean GJ? What?
GJ. Why do you say GJ?
Because GJ and HJ are the same distance.
Very good. Segment GJ and segment HJ are both going to be congruent as well. Because J is on the perpendicular bisector of segment GH, so it's equidistant from the endpoints G and H. What? No way. Yeet. Okay? So, how can we find segment GH? How can we find the length of GH?
I haven't heard a voice drop like that.
B. Okay. B. E. Aggressive. Yeah, no one's going to help us out. Bring it back down, man.
Find the X and then put the X in and then
How do we find X?
make them equal to each other.
Okay, make one equal to each other.
JK, not GK, GK.
Just kidding.
Okay, questions on that?
No.
No. Say that again.
Okay, so if we're finding GH, this whole length, then we're going to set GK equal to KH to find X. If we find X, then we can plug it in, figure out what GH is, okay? So we have X is equal to 1. Questions on that? But X being equal to 1, okay? Okay. So now how do we go back and find GH? Plug it in.
Plug one.
Okay, take 2 times 1,
Oh.
and now what do we do with this 2? That's this length, 2 is this length from G to K. How do we find G to H? Okay, we can plug it in and get 2. Could we have known they were going to be congruent?
Yeah.
Okay, so then what do we do now? We double it, add them together. So the measure of segment GH is 4.
Wait, why did you double it?
Because
Oh,
they're congruent.
okay.
It's only one half.
Questions on that? So, continuing on.
Wait,
Look at the.
go back. You're going so fast, Mr. C.
Thanks.
I was gonna say I just can't
That's
call
what
it
I-
Mr. C
You're the
because
only
I
one that
think of
called me.
Cassidy.
I
think
don't know
that's
why.
not
And then it makes me
Is that
upset.
normal? Short light.
I will never call you Mr. C. You will always be Mr. Carlson. I cannot call you Mr.
You'll never be Santa Claus.
You do not want to call me.
Because
I
Mr.
call
C
her
makes me think of Mr.
I call her
Cassidy.
Hey,
Mr.
Mr.
Cassidy makes me feel uncomfortable, and I just.
Face facial expression on that was
Too
pretty
lazy.
Yeah.
Oh wait, this is being recorded. Don't let us forget.
I'm gonna share it with them.
You're gonna go out.
I actually don't.
Don't.
Hey, Mr. Cassidy, what's up? It's Aubrey.
Okay.
Okay. He already doesn't like me. He tries to kick me out of the band room all the time. And I'm
Because
like,
you're always with Brenda.
Oh.
PDA.
Ooh.
No, PDA.
Mr.
I
Possible.
Jacob.
So, were you recording like the beginning when we were building this wall?
I don't remember.
Is this about to get political?
So it might be on video, and we can just replay it over and
Look
over.
at the following pictures. Segment AB is the perpendicular bisector of each of the following triangles. What do we notice about the perpendicular bisectors here?
They're all in the middle.
They're not necessarily in the middle of what? They're in the middle of the segment.
They're not in the middle of any point.
They're not necessarily going through a vertex, are they?
No.
They're not necessarily going in through a vertex. Here are the previous examples. We had the perpendicular bisector going through the vertex. But here, we don't have that.
So
So what we should notice is that the perpendicular bisector does not necessarily go through the vertex. You don't have to write that all out. What's a short little note you could write yourself to remember this?
The perfect bisector.
Doesn't always go through the vertex. Okay, it could be a much shorter version that you could write. Doesn't always go through the vertex. If that is enough for you, awesome. Just write that. Write something that you're going to remember what we just kind of discovered about this. Wait, it's not always through the vertex.
Mr. Possible.
Yeah.
Super Bowl prediction, go.
What's my what?
Super Bowl prediction.
Super Bowl prediction? I'm going,
Eagles are gonna win again.
No.
3 times in a row.
How about them Cowboys?
Ew, no.
so I'm going, Patriots in it
Ow.
against the
Patriots or ours?
Saints.
Ooh,
All right,
I'm
keep
going
the Huskies
Patriots winning it all.
no.
I want it to be Patriots Rams, but I think it's gonna be Patriots Saints.
No love for the Chiefs.
No love for the Chiefs. Zero love for the
Chiefs are
Chiefs.
gross.
Zero love for the Chiefs. Non-existent defense until last game.
Yeah, you're fast.
Why it's a big juice?
I wish we could give teachers grades.
Me too.
I don't need
We
any
all
more
failed.
answers.
You failed.
would have failed by now.
We need to remember that these things are being recorded when we start saying things.
Oh,
Yeah,
yeah.
Mr. Cox use this all against us. Yeah.
Did we get the shake voice?
And he just like crops it
That's
out
new.
and like edits it. And it's
Please,
just
like,
like,
please, can you do that?
Oh, I can do that.
Please?
Josie, are you?
I
Are you okay? Yes.
She's been like this the entire class.
Yeah.
You guys just haven't noticed.
I don't pay.
Good. Flip the page.
Oh, we get shapes.
We get
Oh,
toys.
boy.
Hey, real quick before I hand more of these out.
Yeah.
Okay, there are sharp pieces. Do not play with these. They are toys. If you play with them, I take them away. And we're not gonna do a fun activity.
We're about to make
So
Hawaii.
no
Or
Right.
one more fun activity. Yeah, definitely no soul fighting. Okay?
We're about
Be
to
responsible with these, okay?
I thought you were
Hawaii into
talking.
existence. So
I'm gonna stab myself.
Hi, Joey.
I'm gonna encourage you right now.
Yes. Walk it back to
Okay, guys, we're about to start Hawaii into existence.
Thank you, Sherlock. Very much.
What? Oh, another one?
One was the-
Oh yeah, Tyler just won.
Yeah, the juice bag.
Throw it at me. Okay.
Yeah.
Was this like early 1900s?
What is up? No.
Pencil.
Guys, watch it.
Oh, you gonna win it.
I don't think I'll be able to make a very big circle.
Look
Oh,
at this
heck
pencil.
yeah, I can.
What?
Oh, hey, yeah. I can do this.
Face the chink, face the slide, face the chink, people.
Never trust me on that one.
Oh. She
Guys,
literally
let's
stabbed
do
me earlier with a pencil.
Yeah, I'm gonna believe you.
Is there anything wrong with that?
Okay, so the next example, we're gonna work on bisecting a segment and actually doing it mathematically with construction. Kind of neat, okay? So we're gonna follow these process. First, excuse me, we're going to place the compass on one of the endpoints of the segment. We're gonna place the compass on one of the endpoints of the segment. So you're gonna have your compass, you're gonna stab it with the stabby part, not the part that's the pencil. Okay? So not the part that's the pencil, the other part. And you're gonna put it on there.
That's actually
The paper.
Okay, so moving on. Moving on. So put the pointy part on one of the points. Put them on point A to start. And then we'll put, you want a setting, so you want them apart, far enough apart to where it's over half the segment, okay? So something like this
I
might
don't
work.
know how to do that.
Okay, you pull it farther apart. So you,
Oh!
does anybody need help changing the setting on theirs?
I got it. I just pulled it.
So you don't tighten and loosen it, yeah, you just do that.
Why?
Over
I
half
don't
or
know.
half?
It doesn't work well.
Something on that?
Wait, so I don't get to drop crazy.
I could be 11 to 10, but it only goes like.
Okay, and everybody getting that?
C.
Okay, awesome. So,
Oh, I see how you do it.
I'm gonna put mine here. What we're gonna do with this is we're gonna make an arc above and below the segment. So what we're gonna do is I'm gonna do this arc and I'm gonna make it like there. So that'd be like my arc above. And this is my arc below.
Gotta stretch it out.
And you gotta make sure that point stays on the dot the whole time. So you make an arc above and below that segment. And being very careful this whole time, you don't want to change your setting after you change it initially. As you
Oh,
change
I
the
didn't
initial
try
setting,
to.
you don't want to change your setting. It has to stay the same for this to work.
Oh,
That is
Has
not.
everybody made the arc after for your first point?
Oh,
Yeah.
Who's still
Oh,
needs
that
help?
was awful.
I don't know if that looks like
Oh,
it.
gosh.
If this was our class, I would have a failing.
You made it move along.
Even like with the tracing thingy. Oh, I really screwed up. Oh, I screwed up.
Yeah.
Alright, need help?
Yeah, that would be good. That would be good. If you have questions on yours, hold them up real quick. That'd be good. That would be good.
That's how you want it.
Yeah, that would work.
That works.
Yeah. So yours is too like wide.
Like that?
It's too like
I thought
away
it
from
was
the front.
too.
That could work, but you need to make your arc longer now. You need to have your pencil. You need to have it long, like a longer arc. So like, Joseph, when I'm saying by longer, you need to have continue it further.
Why is it so pointy?
Okay.
Try not to mess with your.
Does anybody still need help on this? You don't need help, or you don't get it?
I
made the
Got it.
Okay. Yes. No, that's okay.
Were we allowed to complete the
Okay.
circle?
So, I mean, sure, we don't need to, okay? So then, you'll use the same setting, go to the other side, put it on the dot, use the same exact setting, it has to be the same setting, and do the same thing. We'll make the same arcs.
Oh my.
Oopsie daisy. They're like probably gonna be the same.
That's actually what he said.
It looks like a fish.
Oh no, where'd it go?
Mine does.
I figured it out. Oh yeah, she's a beauty.
I swear it wasn't intentional, but
I know that she.
they connected that.
Don't assume it's gender.
Okay.
She's on.
Let's
Next
go.
up.
Did I mess up on mine like terribly?
Oh, mine looks weird.
Yeah.
It
It looks like it. Mine looks like a
Oh my
fruit
gosh, it
bowl.
looks like an Under Armour sign.
Did you say mine looks like a fruit bowl?
Yes.
There we go, that's better. That was
I'm confused. What's
Mr.
the way?
Costa, I need your help.
One
What have
second,
you
let me-
done, Mr. Costa?
Mr. Castle, this is your own experiment.
Ian, when you listen to
Oh.
it,
Oh.
Mr. Howard would be disappointed.
Yeah,
Okay.
Uh,
Mine doesn't look right. Mr. Costa
Doesn't
does
work
that
like
for
a
a reason.
circle.
Okay, so no matter how big or small yours were, I checked all your sizes and they were good. They should still intersect to kind of form like a little X up here and an X down here. You should have two of them. You need two of them for this to work.
You need to go all the way through the second.
I have
No,
two.
no, you just need them to intersect. I just went through because it was easier for me to have them. Okay. Then you would take a straight edge. Your straight edge can be whatever you want it to be. It could be your phone, a calculator, ruler, whatever. Okay. So it's a bendy ruler, right? Okay. Hey, so then
Phone's not
you'll
very
connect
big.
the two intersections. You'll take these two intersections and connect them. Connect these two intersections.
That's not very straight.
Connect the two intersections.
Ooh, that was pretty loud.
When you connect your two intersections, what do you notice you created? A straight line.
Then a vertex.
And what is it doing to this segment AB?
Cutting and baking.
Bisecting.
It bisects it. It cuts it in half. It bisects it.
What?
And furthermore, what kind of bisector is it?
Perpendicular.
It's a perpendicular one. It forms a right angle with this as well.
Whoa.
We constructed a perpendicular bisector
That's a lot of work.
using a compass and a straight edge. That's what these are called a compass. Those little orange and silver things you have, those are called compass.
That's Jake.
In a straight tank like
And a straight edge, okay?
That's
Straight edge. But anything that makes straight edge. Noah uses switch and it works. Riley uses her phone and it works. Use something that has a straight edge, calculator case. Questions over how we made this. Now this is just kind of a cool little extra activity to see, hey, we can make this kind of stuff. And a discovery thing. Faith is like, that's not very cool to
That
me.
is so
Okay.
cool.
Just like stabbing kids.
So
Trying to draw it.
But she's, you actually thought it was interesting? Yeah. you thought. Okay.
He's like, yes, I got something.
So, we can construct three perpendicular bisectors of each triangle. Let's go ahead and try doing this. Okay, we'll follow those same steps we just did, but you'll have to do it on each point and a couple times for the point. You have to choose a setting that's over half.
Scratch it out.
Over half of like the longer side.
Over half of each, whatever side you're doing at the moment. So for here, I chose mine that's 3 inches, or the 3,
Oh, that's a little.
the 3 setting here. So I'm going to do the same setting on this same side of the segment. So you go based on the segment side.
Oh no.
At this moment.
So I'll go through.
Do we go in?
Gary, now I know.
I missed.
I was trying to draw my football.
This is what you do, Owen. This is what it should be.
Okay, it's not for my.
You may not like really what perfection looks like.
What do you do?
What?
You called me a dummy.
So I made one perpendicular bisector. Now I'm going to make my other. I made the one for the bottom side. Now I'm going to make mine for the next 2 sides.
Yeah, erase it.
I can tell you, that's not real.
I messed up my thingy.
Yes, you do one on each point. I messed up the.
Okay, so you know how we just made perpendicular bisectors for one segment?
Here.
We're going to do it for each segment of the triangle. So I did my bottom one first. Now I'm kind of doing this top left segment.
We're being a little extra.
Wait. Owen, I might be right.
What?
Point here. Wait, what is going on?
Owen, I did it right. They
Many
just weren't close enough.
Okay.
Oh look, I did it right. They just weren't close enough. They were too far away. See, just keep them together. I did it right. Yeah, dummy boy, dummy boy. You're still a dummy.
Oh, look at that.
Look, you're missing a 2.
Kind of doing this round.
Oh no, I messed it up again. Oh wait, I remember. I can't do it that way. Hold on. I need to.
Wait,
I did it right,
why
but
are you
wrong.
missing these 2? He's the one that goes through.
I have to.
I know,
Okay,
I said
draw
they're
more
not close
circles
enough.
until I get something
Look,
that
I'm
looks
making the
right.
Illuminati on accident. You're confusing me.
Oh, I see what you did wrong. Yeah, you're a dummy. I'm not a dummy boy. I'm
I'm so confused.
This is actually cool enough. I like
That's music players. This is actually cool now.
I messed up.
No, that's not right. I'm like.
Whoa.
Shut up.
Whoa.
I messed up.
No, don't do that.
That's what he's mine's still looks
No.
I just have to draw one.
All the way
Every
around.
corner.
Give me 1 second to do that.
My hands are shaking too fast.
I got away with it. Yeah, it does.
It's really just drawing a bunch of circles that doesn't make sense. Why? At this point, there's so many lines on the
I
paper
don't
that I
even.
don't
I'm
know.
lost.
I lost on that.
You didn't catch your.
Okay. Well, everybody look at mine real quick. If it was more accurate on the whiteboard, it's less accurate than on the paper. I did it more accurately on my paper, but as on the whiteboard, it's a lot harder to keep this compass from moving than it is your guys' compass. But they should all 3 intersect at the same point, and as you can see before I do this, they were very close to all 3 lines intersecting at the same point. I made 3 perpendicular bisectors in blue here, and they were all very close to intersecting at the same point. Please everyone look up here real quick. Okay, take a
minute, take a break from what you're doing, look up here. So all three of my perpendicular bisectors are in blue. And as you can see, they're very close to all intersecting at the same spot, right? Now, if I had done this perfectly, my compass moved a little bit more than I would have liked, okay? And the calibration can be off. But those are all very close to intersecting at the same point. So they should intersect at the same point when you draw them all the way through. Notice I had to keep going and mine connected outside the triangle. And all of them, if you do yours correctly, should connect in kind of in the same area, right below the triangle here. Okay? Let me kind of look around at your res real quick. So if you are needing help, raise your hand on this, okay? I'll come around
I
real
just
quick.
am way off and I need a new triangle.
Okay.
I create a perfect X, just barely on time in that one.
Let's look at the arc you did, okay? The arc you did from here to here, is that over half the segment? Oh, you can do over half the segment. So you can go like here, that's over half the segment, right? So you can do it there. And then you wash it out, way up here. Then you can swing it through all the way. And then get the same setting.
Well,
And that's right, because I didn't know what's wrong with that. That's perfectly fine.
Is that like a little bit more in the middle? Does that make sense? So the only difference that I do between yours and mine is I had to make sure that this is over half this distance. So for this one, it has to be over half this distance.
Why don't the conversion is that like trying to
Like something like that.
all in
I
one
mean, I
way?
will.
Does that make sense? Peg buddy, that's how it's finished. Yeah, so you
can I use Jamaica?
Mine's clean, but like it doesn't go where it's supposed to.
Mine just looks like something, I lost my
I even checked this,
So,
and it's
My crosses.
so now if we do this one, is that where did you
in a sterilized meat.
Freaking nailed it.
Wow.
Oh no.
Flamingo. Yeah, okay, I understand because I know I did wrong. I did it. It's not right, but I did it. I did it clean, and it's still like wrong. There's one at least like a foot within like the target area. If we're at
Okay,
least like
do
a
all
foot
of them
away from the
have
target
to,
area.
I need a new triangle.
Not from where about your triangle.
Listen, I don't know what lines I've drawn and what.
Yeah. I keep track. That sounds like a problem.
I don't get that joke. You joke about that, man.
So this should make it.
I don't get it.
That's what I did. Try like now. I should be able to kind of spin this and like I would hold it or go like this and then kind of move it around. Boyfriend, we'll try that best friend.
See, I didn't do it right, and I can't even tell which one I did right.
Boom.
Mr. Cosmo.
I did it forward. Jamaica didn't
Keep going.
Now, let's see the bisect thing, right? So we can do the same thing on this, just making sure that this measurement is over half of this, not the whole thing, so back and forth.
Brady.
Okay, so I think we kind of got through and kind of went around, surveyed this, and I think we're kind of getting the hang of this a little bit now. So the first time we use a compass, I expect that to kind of be rocky, okay? So now this point where all three of our perpendicular bisectors of a triangle, right? There's only going to be three perpendicular bisectors of a triangle. Like there's only one perpendicular bisector for each segment. So this bottom segment only has one perpendicular bisector. There's only one spot that something can bisect at a perpendicular angle. Same thing with this top left side, same thing with this top right side. So there are a total of three perpendicular bisectors for any triangle. There's many perpendicular bisectors as there are sides, three perpendicular bisectors, four, three. Now, we have this thing that we're going to call concurrent lines. Concurrent lines. Concurrent lines are three or more lines that intersect at the same point. Did we just have that with our drawings of three perpendicular bisectors?
Yeah.
We did. But up here we did, right? Okay? So those three perpendicular bisectors would be what we call concurrent. Now, the point of intersection of these lines is called the point of concurrency. Very good. So in this case, that point is point C. So in this case, point C is our point of concurrency.
Always labeled as
Oh,
point C.
Yeah,
That's just in this.
Don't touch one. Wait, is it always like point C or just that?
that's just what it is in this one. So it's not always, it doesn't always have to be point C. I get that for circumcenter, or not for circumcenter, for point of concurrency, but it doesn't always have to be C. It's just C in this example. It can be any point. In this case, it's just point C. Questions on this idea of concurrent lines? Okay, so we're going to talk about a certain kind of concurrent line, or three concurrent lines. Whereas if we have the three perpendicular bisectors, like we did on my drawing, the three perpendicular bisectors of the sides of a triangle intersect at a point that is equidistant from the vertices of the triangle. And we call that point the circumcenter. So going back to here, this point where all three of these perpendicular bisectors connect or intersect would be called our circumcenter. Circumcenter. You might want to label that on your drawing. Circumcenter. It's called the circumcenter. Now the circumcenter is equidistant from all of the vertices. So if we were to go through and measure this point, this circumcenter, from this vertice to this vertice to this vertice, vertex, this vertex to this vertex to this vertex, all three vertices, then it would be equidistant. That's just a fact about the circumcenter of a triangle, the point of concurrency of the three perpendicular bisectors. So as it shows in here, the distance from this circumcenter is the intersection of this perpendicular bisector, this perpendicular bisector, and this perpendicular bisector. It's equidistant from each of these vertices. Does that kind of make sense? Okay, I know it's a new concept to us, but does it make sense? On Friday, we will talk about using properties of the concurrency, of the circumcenter, excuse me. I want you guys to go ahead and pack up. You have a couple minutes, so feel free to work on other stuff, either for this class or something else. When is that homework going to be due, that 4A homework?
Friday.
Friday.
Tomorrow.
Do not throw those compass, do not throw the compass, they are sharp objects. Yeah, you throw them.
Stab me twice.
No, just one. You're actually a border patrol, so I don't know if that's illegal.
Border patrol.
Border patrol, you get
You
arrested
see
for
that
crossing
show?
the border.
There's like a, it's like border life.